onto a sphere, then I've got to break out a whole new set of geometric rules. I've got to redefine asymptote, I've got to redefine line, I've got to redefine triangle.
But isn't it, if you have something, if it doesn't eventually hit where it started from?
Not if it's an infinite plane. Mathematically, we can envision an infinite plane, or we can project that plane on. We're just talking about projecting that plane onto a sphere.
Well, just not, well, I guess not a sphere, but like in the universe, you're going straight infinite, would you eventually go to where you started?
Only if space is curved. That's not proven yet. All right. That was relevant to the homework tonight. No. Okay, for that, you should be able to match that, use the graph. Okay, transformations. I'm going to jump right from this, because we did this last year. I'm going to make an assumption, and you may have to do some reading in your book if the assumption is wrong, that you'll be good, that you'll remember if you, what to do if, with plugged-in numbers. That may be a bad assumption. Actually, I'll do one more thing first. What is y equals, I'll just do this. What if we have a fraction inside here? What if we have a fraction inside here?
You distribute each separately, like the numerator?
I could. So that could be 1 to the x over n to the x. No matter what x is, what's 1 times itself, however many times you want to do it. So this is 1 over n to the x. Can I write that as n to the negative x?
Yes.
Yes. Remember your negative exponent rules. Actually, Matt, I'm glad you asked that. You said that because the point I was going to get to is these three things I'm boxing here will all graph the same exponential function. All graph the exact same one. Okay? And that function is going to behave similarly to this. Now let me make a little table again. I'll leave a little room for this. Let's see, x, and now I'll use this one, n to the negative x. When x is negative 1, what do you get when you plug that in to here?
1.
You get 1. Negative of a negative is its opposite. So you just get n to the first power, which is n. When I put in 0, what do I get?
0.
I get still n to the 0.
Mr. B,
Yes.
you wrote n to the 1, not n to the negative 1.
That was intentional, because negative x will switch the sign.
Oh, okay.
Right. But double check me on that. I put in 0, I get n to the negative 0, which is still 0, and that's still 1. I gotta get you your other part. Okay, hang on a sec. Okay, I put in 1. What do I get?
N to the negative 1.
N to the negative 1, which means what? 1 over n to the first. Very good. I put a 2 in. What do I get? I get n to the negative 2.
1 over n squared.
Yep. And now I put in 3, and I get n to the negative 3, which is 1 over n cubed. As this denominator keeps getting larger, as I square and cube this number, what happens to the whole fraction?
It gets smaller.
The whole fraction gets smaller. Very good. So this graph still passes through 0, 1. At negative 1, I get my n value, which the way I've set that up has to be somewhere up here. And then at, turning it in, Drew?
Yeah, but I'll come back to that one.
Okay, set it on the keyboard.
I have 2 questions.
Okay. Now, put that there. Whoops. And this is going to keep getting smaller and smaller.
Whatever hit the
So it's a negative
Nope.
asymptote?
Never. It's still, the x-axis is still an asymptote. Okay. Now, sorry, Amy?
It's negative?
This could be y equals 1 over n to the positive x.
No, I'm saying like the asymptote is negative.
The asymptote is still just y equals 0. It's still just the x-axis. But it's happening on the positive side now. Okay, these are all positive numbers up here. And this is positive x. There's no negative.
Y equals 0, x equals infinity.
The limit of f of x
The limit does not exist.
as x approaches infinity.
Wait, where's that from?
Thank you, Lindsay Lohan. Bean Girls, the mathlete subplot. Equals 0 is how I would write that. Okay?
The closest to 0 gets it. Like, it's like minus 1.
You can keep going as far as you want. And in calculus, you can reach infinity. So,
Once they, so it's like if you had an opposite on the bottom half, and both the arrows are going the same direction, these closest together when they get you infinity.
yeah, assuming you can imagine what reaching infinity means. Okay.
Will that defeat the first?
Can you reach infinity if you go what's it called? Speed of light?
No.
It's not infinity anymore.
There's an old bad joke about that, and you're ready for abstract math if you actually think this is funny or clever. Hang on, Sam. An old bad joke about that. Man goes into the Infinite Hotel. Desk clerk says, I'm really sorry because this is the Infinite Hotel, but we're actually full up. Man says, oh, that's a shame, but I have an idea. How about if everybody picks up all their stuff and moves one room over to the left, and I'll just take this first room here. Guy behind the desk clerk says, oh, that'll work fine. That you can, you can do that even if the Infinite Hotel is full. Okay, Amy, give us a break on that.